My name's Mordechai, and I'm the data team lead at IronScales. So what are we going to talk about? Basically, I'm going to answer 4 questions and give some library overview and code examples. So what is Apache Avro? Why is a schema registry important? What are some challenges with integrating AWS Schema Registry? And how can AWS Glue Schema Registry library help? And finally, we're going to do some code examples. So first of all, what is IronScales? IronScales is a SaaS solution for detecting phishing emails in real time. So we have about 1 million protected mailboxes. We expect maybe 100 million emails per day. If you assume that the average email size is 40 kilobytes, so you can do the math, about 30 billion monthly emails and 1.2 petabytes of data just per month. Cool. So in order to solve this problem, we have a real-time big data machine learning system. Wow, lots of buzzwords. Okay, so how does it work? First of all, we have the inspect flow, which is basically the main application which processes emails that are coming in from APIs such as Office 365 and Gmail. We take those emails, we push them to some Kafka topics, we have some stream and batch pipelines, we write them to a data lake, then we extract them, put them in a feature store, and then we have like some key value real-time feature store. Then we have some machine learning engine stuff here, which basically takes the information from the feature store, takes the emails from the inspect flow, makes a prediction. Cool. So kind of the data layer that I'm going to try to work through a solution for is we have this main application. We're writing these messages to a topic, and we're reading them with some Python workers with Airflow or some PySpark jobs with EMR. Then we're also trying to write them to the data lake. We have a S3 Parquet file data lake. We use Glue with like Hive as for the schema data, and then we're reading with like Athena Presto and also PySpark. So when designing the system, we noticed that we were having some trouble with reading and writing data to Kafka topics using JSON format. First of all, the downstream field type discovery. For example, let's say we were writing some messages with nullable fields, some with integers, some with big integers, something like that. Then we were writing multiple files to S3. Some files had null fields or null types. Some had int types, some had date types or something like that. Then we're trying to merge them downstream and coming with some issues. Second of all, we're trying to validate these messages downstream, and we had trouble validating them without understanding the types. Also, data transfer costs for sending JSON messages was kind of high, especially across regions. And fourthly, upgrading our Kafka topics to new message formats was kind of causing a lot of issues. So this kind of brings us to Apache Avro. So what is Apache Avro? Anybody know what Apache Avro is? Go once. All right, this guy. What's Apache Avro?
It's a file format for streaming compression.
Awesome. Yes, that is exactly what it is. It is a data serialization framework. So some advantages over Avro. Avro has over JSON. So first of all, if you're using Avro, you have strongly typed data. You have a schema, you know the types of all of your fields. Second of all, your messages are smaller. And part of this is because you can write optionally only the message values, which means that you can save space beyond the possibility of compression by having simply smaller messages. Fourthly, now that you have a schema, you can validate your messages. You have to build expensive, application level validation. On the other hand, because it uses this binary format, you can actually read the data at rest. You have to deserialize it to read it. But maybe that's a fair trade-off. Okay, so one of the advantages with Apache Avro is that you have schema evolution, which basically means you can upgrade your schema to support new changes. So there's a bunch of different types of schema evolution. There's backward, forward, blah, blah, blah. Basically, all you have to imagine is look at the example case. Let's, for example, look at backwards. So what this means is that every new schema, you can add optional fields. You upgrade the consumer reads the new messages. It imagines like the producer doesn't know that they're fields, so it doesn't write anything. The consumer puts some null values, and then you upgrade the producer, and then add new data to the optional fields, and then the consumer is able to read them. This is how you can migrate forward. You also have other types of schema evolution, whatever system, something like that. Cool stuff. So this is some like Python example for using fast Avro, which is the Python library for Avro. Okay, so basically we import fast Avro. We import the schemaless writer and the writer. Basically the difference is that the writer will write the message with the schema and the schemaless will write it without it. And this parse schema function, we import JSON and some OS functions. Here we define the schema. So in this schema, we have basically the schema is for a user. Our user has a name and has a favorite number, which is an integer, or well, it's optional. Okay, so how do we use it? We parse the schema using this parse schema function. So it converts it into this native object, which we can use for serialization. We define the message. So here our message is hello. Our favorite number is 10. And then we write it. In this example, we write it with the schema, without the schema, and we use JSON as a benchmark. So how does it look? First of all, you notice that the JSON message is 40 bytes and the data without the schema is 8 bytes. So we achieved 80% compression by just switching from JSON to Avro without any additional implementation like STD or ZSTD or whatever. However, if you send the schema with the data for every message, the message size is huge. So we probably don't want to do that. And that's why schema registries are important. So with the schema registry, you can share a schema between the producer and the consumer. You don't have to write the schema with every message. And you can only write it once. So for example, for every schema version, you write it once to the schema registry. The producer uses it, your consumer is able to receive messages, check which schema is relevant, and deserialize them. Okay, so that brings us to AWS Glue Schema Registry. So AWS Glue Schema Registry is yet another AWS service. Since we're using MSK, we might want to use like another AWS service. So this is kind of how it looks. Basically, from the UI, you have a schema registry here. You just click on the button. Here we have the schema the specific schema registry is called Avro test. So it's a test. We have some schemas here. If we click on a specific schema, you can see that we configured the compatibility mode and we have uploaded a specific version. And if we go to that specific version, we can see the message. However, there are some challenges with integrating AWS Schema Registry. Anyone have an idea of what some of those challenges could be? Latency, okay. Propagate ID. Any other ideas? So, I mean, if you think about it, regarding latency, maybe it might not be a problem because you're already using some other schema registries, so latency is basically equivalent. With propagating the ID, that might be a challenge, but again, it's similar to using other schema registries. What? Okay, evolution of schema. So the thing is that AWS Glue also supports schema evolution. So it has some, basically it's compatible in the terms of the capabilities. Great question. So that kind of gets into our comparison. So the Glue Schema Registry has some differences to Confluence. And so let's go through them. First of all, Confluence and Hortonworks and others have a standard API for the schema registry that AWS Glue does not comply with. So if you want like drop-in compatibility, you're fucked. All right. But on the other hand, if you're using AWS Glue for other metadata, for example, for us, we use it for Hive tables for S3, then it makes sense to continue using it. And if you're using managed Kafka through AWS, why not use yet another AWS Glue service? However, again, if you want more cloud agnostic solution, if you don't mind fragmented metadata assets, then you can use like Confluence and other services for like other types of metadata. What was that? All right, so Baba. All right, cool. So AWS Glue is not it's not too expensive. You're talking about $1 per 1 million requests. Since you're only really using Schema Registry when you're initializing the client, you don't see cost there too much. However, you have to use this really annoying Java integration library, and it sucks. Okay, so this is how AWS Glue Schema Registry helps. It's a Python library that allows you to integrate with AWS Schema Registry. It's maintained by Disaster Aware, thank God. And it allows you to produce and consume messages in Python, as all the advantages of AWS Glue without their custom Java solution, and it integrates nicely with Kafka Python, which is the popular Python Kafka client. However, it doesn't integrate with Confluent as typo. Okay, doesn't integrate with Confluence Kafka, and if you want to integrate with PySpark, also it might be a little bit of a problem. We ran into that ourselves. All right, cool. So any questions about the presentation, and then I'll get into some code. Yeah, in the back. Oh, yeah. So the question is, do I need to write the schema version for each message? And the answer is no, it's built in. Does that answer your question? All right, cool. Any other questions?
What I understand from your question is you said it's like $1 for each million requests, right? So is it cash, or do I have to call Schema Registry on each and every read for Kafka?
No, so every time you request the schema from Kafka, from the registry, it counts as one request for the schema.
Right, but if I consume a message, I don't have to...
Correct. So for example, if you initialize the client 1 million times per second for every message that you consume, it's probably not a good use pattern, regardless of whether you use AWS Glue.
Yeah. So how does the ID propagate with the headers?
Yes. So actually, the first 18 bytes of the message include some information about the configuration and like the schema and everything like that. So it's built into the library. All right, so this is PyCharm. Basically, I have an application that integrates with this library. So let's kind of go through the imports really quickly. Okay, so first of all, we're importing Botu 3. We're importing this schema registry library, importing Kafka, importing consumers, and then some MyPyBotu library. This is basically just a library that adds type hints to Botu API. Okay, and then we have like some other stuff here. Oh shit. 1 second. Okay, cool. All right, so basically, first off, we initialize the Glue client. So this is a Botu session. All right, so then we pass the Botu session to this get schema function, which basically takes the Glue client. It calls two methods, the list schemas and this get schema version. Oh, it's really big. Okay, so basically it calls the list schemas, then it iterates over the values. The schema returns this list schema response type, which is basically the list of schema registry name, schema name, and then like the specific schema IDs. Okay, and then it goes through it. For each schema in the schema registry, it gets a schema version. So we're just taking the latest version for this use case. It returns this get schema version response type, which is schema version ID, some metadata, and then most importantly, the schema definition, which is the JSON format. And then takes the schema definition, loads it in this Avro schema, which is a wrapper around the Avro object. We basically initializes an Avro object, which is able to use the JSON to serialize messages. And so basically we have this dictionary. All right, cool. So now we initialize the serializer. We have this Kafka serializer object. Basically, it just has the serialize method. And then we do the same thing for the deserializer. And then we initialize the producer and the consumer. So here we have the producer. We pass the serializer, which is the Avro serializer, which is basically just this basically wraparound glue around, and then it wraps the wrapper with this Kafka serializer object. And then we do the same thing with the Avro consumer. So we're passing the Avro deserializer method. And then this kind of natively integrates with Kafka Python so that it will automatically recognize the API for this deserializer and serializer object so that it can use them for the operations natively. Okay, so for example, in this, we're using some like fast API service. So here we have an endpoint sent to this topic using this message. Here we have a send function. You wrap when you're sending the message, you just have to use a tuple with the value and the schema. So the schema here is from the schema definitions. And then it will send the message. Cool. And then the consumer side, you have a read, you're reading from this topic. And then basically all it's doing is loading the partitions for that topic using the Kafka Python metadata in the client. So here it initializes the clients, the partitions, here it assigns them to the consumer, and then it reads the messages. So there's two layers in when we're reading the message. First, there's the consumer record, which is a native Kafka Python result, which is basically topic, partition, offset, timestamp, blah, blah, blah for a specific message. And the actual content of the message is this data and schema format. So this is basically name tuple. You have the data and the schema for that message as well. And yeah. Okay, yeah, so that's a great question. Okay, so the question is, when sending the message, why do I also have to send the schema? That's the question. Okay. And the answer is basically, you're not actually sending the schema. What you're doing is you're serializing the message with the schema. And because we're passing this Avro serializer to the Kafka producer, basically we need to pass the schema as well so that it knows which schema to use for that message. And it does that natively within the Kafka producer, which is like the Kafka Python client. And it doesn't actually send the message, but you just pass it to the client and then it does everything. Does that answer your question? Cool. All right, so basically, yeah, so we read from the consumer, we get the consumer record, we extract the data and schema, and then we extract the data from the data and schema. And that's pretty much all there is to it. So let's give it a test run. Okay, here, so we're going to try to send some messages. We got the message. Name is Mordechai. My favorite number is 42. Okay, I'm going to try to send that. Okay, so I sent it. I'm going to send it a few times. All right, and then we have, okay, so then we want to flush the batch accumulator, which is like the local buffer for sending to Kafka, because we configure it to send in batches. Okay, so I flushed it a few times. Sometimes it lags for a few seconds. So let's try to read. Nope, didn't work. Aha, it worked. Okay, so I was able to. All right, it's a great surprise. All right, so anyways, it worked. So I was able to read a bunch of messages, and everything works as I prepared. Awesome. That's pretty much it. There's not much magic to it. Anyways, I thought it was pretty cool. We're working with it on our team. We're also hiring. So if you are a data engineer, machine learning platform engineer, big data product manager, backend engineer, or data analyst, or other positions, we're all hiring from everything pretty much. So just talk to me, talk to Lomi, talk to Diana, and then that's pretty much it. Any questions about the presentation? Yeah. The question is, which compatibility mode do I use? Backward. Yeah. So the question is, which schema evolution configuration do I use? So I use backward, which means that I'm allowed to delete fields, but I have to add optional fields. I can't add mandatory fields, and I would upgrade the consumer first. Does that answer your question? Yeah. Yeah. Okay. So I think the question is what's the workflow for upgrading with new schemas or something like this? Okay. So basically you have some type of staging environment for both producers and consumers. That's correct? All right. So assuming that's the case, you would want to create a new version of the schema, and then upgrade the consumers to read that new version of the schema while the producers are still using the current version. All right. If that works, then once you upgrade the producers, everything will basically be fine. Because these fields are optional, or assuming that you're adding fields, right? So you're adding optional fields. So when the consumer reads them, even though the producer is using an old schema, since the fields are optional, if it doesn't see it, it assumes that it's null or some, default value. And then when you upgrade the producer, you're adding new data to those optional fields. So that means that the consumer can recognize those fields when they become available. Does that answer your question? All right, cool. Well, thanks for taking this.